Hi, this experiment for elementary school students is called floating and sinking, and I break the students into groups of 4 or 5 so they all can, each group can replicate the experiments. There's a number of different parts to this experiment, and depending upon your class, you may be able to do them all in a 1-hour session, which is our typical duration, or you might have to cut back, or you might have to stretch it out till 2 sessions. The vocabulary introduced for this particular session: density, buoyancy, salinity, and tides. Density is kind of a complicated concept for these young students to get their heads around, so I approach it, but I don't necessarily nail it. I want them to learn about floating and sinking without necessarily getting into the specific gravity and concepts like that. That might be a little bit too complicated for them. I find that this is a good experiment to kind of teach the scientific method, or to, if not to teach it, then to reinforce the scientific method. And you can kind of get a sense by asking the students early on, or talking to the teacher about whether they've covered the scientific method or not. And you might approach it differently depending upon whether they've already studied the scientific method. But I start by saying the first step is what do we already know, or what is the first step back, even before that, what is the question? And today our question is going to be what makes things float and what makes things sink. And then I ask the students, what do we already know about floating and sinking? And if they need another prompt beyond that, I ask them to give me examples of things that they know will float and things that they know will sink. And then the next step is developing a hypothesis. I have that. That is a concept that I use in other sessions as a vocabulary word. If it hasn't been introduced by the time I get to this session, I will introduce hypotheses as well. And it's a guess based on the information that we already know. So I do ask the students to give me some suggestions on what might make things float and what might make things sink based on what they already know. A common hypothesis is that heavy things will sink and light things will float. So I use the scales in this one, and I'll have the students start. Each group will have someone to start by weighing a baseball, and then they weigh a golf ball, and then we place them in water, and they're to observe which one floats and which one sinks. The golf ball sinks, the baseball floats, and the concept there is that it's something in addition to weight that affects floating and sinking. Otherwise, the heavier baseball would sink while the lighter golf ball would float. This is a little bin, a little plastic bin that I picked up, I think, at the dollar store that I use in that facet of the experiment. I then will talk a bit about the forces that are acting on the object that we place in the water. And what do we have pulling down on that? We have gravity pulling down. And what do we have pushing up? And that's when I introduce the concept of buoyancy as a force in water that pushes up on the object. And whether an object floats or sinks will depend upon whether the gravity force is larger than the buoyancy force, or whether it's smaller than the buoyancy force, or than the gravity force. And if the gravity force is stronger, the object will sink. If the buoyancy force is stronger, the object will float. Often when I do this, I'll draw a profile on the board of a surface of water with a ball half under and half on top of the water, and draw the forces that are acting upon that. I bring in the concept of it's not just the weight of the object, but it's the shape of the object as well. And since This particular, the baseball has a larger surface upon which the buoyancy force can act. The buoyancy force is going to be stronger on the baseball than on the golf ball. And I'll introduce the vocabulary of density, if not the complete scientific concept of density. But that density is a measure that combines the weight of the object and the shape of the object, and will determine what forces act upon that. I then have the students take a lacrosse ball, and this can also be done with an egg, hard-boiled if you're working with young students, less messy. And I fill one of these, I think it's a 16-ounce plastic cup with water, and I have the students place the lacrosse ball in the water and observe whether it floats or sinks. It'll sink, and then I'll have them add salt to the water, and I think I use about a third of a cup for this, but I always play around with it before I go to class to make sure that it'll be sufficient. And then I have them stir that salt into the water in the cup, and once it's dissolved, I have them put the lacrosse ball back into the cup, and this time it will float. And this is the way I introduce concepts of salinity and the fact that salt water has a higher buoyancy force pushing up on the object than does fresh water. I ask them where they might find fresh water, where they might find salt water. Most of the students I've worked with do know that there's a difference between water in the ocean and other water. And I talk about fresh water being in ponds, streams, lakes, bays. I often will use the Chesapeake Bay because that's where we're located. Although when we get into estuaries like the Chesapeake Bay, it's a mix of salt and fresh water, and I'll address that in a minute. And they will find fresh water in their bathtubs and their sinks at home as well as what comes out of the water fountain. Then when we have we've shown that the salt water, that the egg or the lacrosse ball floats in the salt water and sinks in the fresh water, and get through that concept of different buoyancies associated with them. Again, I don't get into too much about the different density of salt water versus fresh water. You can do that if you have older students. But I'll have them pour a little bit of the salt water into just a very small cup, and I'll take one of these transparent, looks like an 8-ounce cup, and they will have their salt water, just a little bit of salt water in the bottom of this cup. I have them add